Hello, this information session is on Smart Irrigation Controller Technology. From Stanford's Water Efficiency Program, I'm Jennifer Fitch, and presenting with me today will be Dan Palmer from On Point Ecosystems. During this session, we'll talk about the benefits of weather-based or smart irrigation controllers, the difference between smart and standard clock controllers, go over how smart controllers work, and Dan will expand on the technology in Stanford's pilot study. Smart controllers have been used for many years on the Stanford campus in high-profile areas like the Oval and the School of Medicine. Campus sites with smart controllers saved up to 30% of their water use last year. The Water Efficiency Program started a pilot study in the summer of 2014 to test smart controllers at single-family homes. The pilot study group saved 30% of their water use, compared to others not in the pilot study who saved 21%. This was due to drought restrictions and conservation messaging. During the pilot study, we used an integrated approach, including landscape surveys and requiring irrigation repairs be completed. Smart controllers do a good job of saving water, but you have to have a working irrigation system as well. If you have a broken pipe, it doesn't matter how smart the controller is, it will still waste a lot of water. So what have we learned by using smart irrigation controllers at Stanford? Well, smart controllers have the potential to save a lot of water, and without compromising the landscaping. It's a proven technology, but initial programming is very different than standard clock controllers. Training is necessary to understand the technology, how to program it, and how to operate it properly. Our goal is to provide facts about smart controllers for campus residents as they consider changing to smart controllers. Stanford's Smart Irrigation Controller pilot study began in July 2014 and included 19 participants who installed smart controllers at their homes. During the first 7 months of the pilot study, these 19 homes saw a 30% reduction in their water use compared to the previous year. This was a total of 1.7 million gallons. Pilot study participants reduced water use by 30%, shown in the green bar. This was 50% higher than the homes not in our pilot study, shown as the blue bar. The blue bar is showing current water savings from non-study participants. If 25% of this group converted to smart irrigation controllers, we could see additional savings of over 2 million gallons. For comparison, one of the larger buildings on campus, Y2E2, used about 500,000 gallons in 2014. The additional 2 million gallons saved from smart controller conversions could provide high-quality domestic water for academic and research buildings on campus for over a year. Last year, we did a pilot study on smart irrigation controllers, and this year we're adding a second phase. We're looking for 20 participants who used over 1,000 gallons per day during the summer of 2013, who have had a landscape survey, have repaired any irrigation issues that were found, and have completed training on smart controllers. The pilot study uses On Point Ecosystems WaterSage smart irrigation controllers. Participants will get a combined rebate from Stanford Utilities and the Santa Clara Valley Water District. And you get to give your feedback on the controller, your landscape, and the usability. We really want to hear from you. Even if you do not qualify for the pilot study, there are extensive rebates available through the Santa Clara Valley Water District. The next section is on efficient watering of residential landscapes. We will go over the basics of efficient outdoor watering, how smart controllers work and how they differ from standard clock controllers, and key features to consider when selecting a smart controller. The basics of efficient outdoor watering include your landscape design, selecting plants that are appropriate for this climate, as well as grouping plants by their water needs, or hydrozoning. Having high water use plants on one station and low water use plants on a separate station. Having efficient irrigation equipment. This includes the irrigation system as well as the controller. And having an appropriate watering schedule. In addition to having a weather-based irrigation controller, a landscape with an efficient irrigation system will have the following. 1. Matching sprinkler head types. This will prevent over- or underwatering of landscape areas due to the fact that different heads apply water at different rates. 2. Heads that apply water at the same rate that the soil can absorb it. This will prevent runoff. An example is the stream rotor pictured here. 3. Check valves. Prevent water from draining from the lowest heads on sloped areas. 4. Sprinklers operating at the correct pressure. Misting from spray stations is an indication that the pressure is too high. This can be remedied by a pressure regulator. 5. Well-maintained drip emitters and drip lines. For healthy plants, water from rainfall and supplemented by irrigation should penetrate the soil and be absorbed into the root zone. Water will be lost through evaporation, transpiration, which is evaporation from the plant, and runoff, which occurs when water is applied faster than can be absorbed into the soil. Smart controllers calculate how much water plants need by figuring out how much water was lost through evaporation and transpiration. This is called evapotranspiration, or ET. The ET factor depends on the temperature, the amount of sunlight, wind, and humidity. ET varies throughout the year as the days lengthen and the position of the sun changes. It also varies between different plant species. Now, irrigation controller technology has advanced over time. You may have had a mechanical fixed-time irrigation controller at one point. This has evolved to an electronic fixed-time controller. Most people have something similar to this controller. And the latest evolution is weather-based controllers. These controllers automatically adjust the watering schedule each day in response to the weather. Now I know you're interested in smart controllers because you're watching this video, but you probably have some questions, like how much do they cost? Where do you get them? How do you program it? And of course, which one should you get? Well, smart controllers come in a wide range of prices. It depends on which features you select. You can purchase smart controllers at an irrigation supply store like Ewing or Horizon. You can purchase them directly from the manufacturer or online. For help in programming the controller, there are many instructional videos available online at YouTube and from some manufacturers. When considering which smart controller to purchase, you want to think about factors such as where does the weather data come from? Can you access it remotely? And how does the controller calculate the watering schedule? Now, the first thing to consider when selecting a smart controller is the type of weather sensor. There are two main types of weather sensors for smart controllers. Commercial weather stations, they gather information on sunlight, wind, temperature, and rainfall in your local area. And on-site weather sensors, these need to be installed at your home, and they gather some or all of the same information, including sunlight, wind, temperature, and rainfall. The next thing to consider is, can the controller be accessed remotely? There are many different types of controllers. Some have built-in remote access, and some have add-on components that you can use to upgrade the controller to have remote access. Add-on features often come with an additional price. Another thing to consider is, how does the controller calculate the watering schedule? For controllers that use landscape factors, the user inputs information about each watering station. For example, what type of plant, soil, irrigation, etc. The controller will then calculate a peak or summer watering schedule and will automatically adjust each day's schedule based on the ET factor. For controllers that use a percent adjust, the user inputs the summer schedule, then the controller adjusts each day's schedule based on the weather. Now Dan Palmer from OnPoint Ecosystems will tell you more about the WaterSage Smart Controller, which is being used in the Stanford pilot study.
Thank you, Jennifer, and thank you for viewing this online seminar. One of the main challenges with smart controllers is complexity. If you thought your current controller was challenging to use, smart controllers can be daunting. WaterSage addresses this by making smart irrigation easy. The WaterSage solution consists of an irrigation controller and cloud service called MyOnPoint. MyOnPoint collects daily weather from a commercial weather station here on campus and calculates an optimized irrigation schedule for each zone every day. MyOnPoint also allows easy access to the WaterSage controller from virtually anywhere using a smartphone, tablet, or computer. After installation and setup, program WaterSage using the Landscape Wizard. Simply select the pictures, plant, sun, slope, soil, and irrigation, most closely matching each zone, and WaterSage recommends the peak total time for that zone and a maximum cycle time to avoid runoff. In this case, the zone is watering a lawn with partial shade, a bit of a slope, and clay soil. The sprinkler type is spray. It's important to note that the peak total time represents a typical water day in July, and actual watering will vary depending on weather and the time of year. Also note the words zone, valve, and station are interchangeable. It's also a good idea to take a picture of or write down the settings of your current controller and zone locations before disconnecting it, so you have that information to refer to as you program WaterSage. Looking at another example, shrubs instead of lawn, again simply select the pictures most closely matching the zone, and WaterSage once again recommends the peak runtime. In this case, there is no maximum cycle time because runoff is not expected since the irrigation setting is drip, which in most cases applies water more slowly than spray. Once again, the recommended peak runtime is for a typical water day in July and is only a reference point. To see how the controller is actually planning on watering for the upcoming 2 weeks, simply look at the estimated watering in the water use report. Once programmed, WaterSage will automatically adjust irrigation on a daily basis. Let's take a closer look at how it does this. First, the zone information we just programmed is used to define a plant root zone. Think of it as a glass with a plant in it. The glass represents the water holding capacity of the root zone, and the moisture balance, how much water is needed to fill the glass. Looking at an irrigation schedule that waters every 3 days, Day 1 is a watering day, and the root zone is filled by irrigation. The plant also uses and loses water on Day 1, a process called evapotranspiration that Jennifer discussed earlier. The plant uses more water on Day 2, and the root zone is further depleted. Although the plant uses water on Day 3, rainfall exceeds evapotranspiration, increasing water in the root zone. Day 4 is the next water day, and WaterSage only applies the amount of water needed to refill the root zone. So what will WaterSage do on a typical July water day for the previous example? At the beginning of the day, my OnPoint gets weather information and determines the total ET, or water loss, since the last water day, and notes there has been no precipitation. The ET of 0.57 inches, along with the landscape settings for each zone, are used to create an optimized irrigation schedule for all zones, including cycle and soak times. Because it's a typical July water day, note that WaterSage runs each zone the peak runtime. Now on an October water day, WaterSage goes through the same process, getting the ET and precipitation information. Then along with the landscape settings, it computes an optimized irrigation schedule. And even though this period in October was sunny and hot since the last water day, ET in October is significantly less than July, and WaterSage waters less than half of the peak or July run times. With a focus on simplicity, you shouldn't be surprised that WaterSage is easy to install and set up. A setup wizard guides you through the process, and replacing your existing controller is easy because of WaterSage's removable connectors and compact size. And it's easy to use. Turn valves on and off manually from the convenience of your smartphone, run diagnostic tests to isolate wiring and valve issues, and on-screen help is available for any function. And if you want to know more about what WaterSage has done and is planning to do, dig into the numerous reports on events, water use, both historical and forecasted, details on today's irrigation plan, and current root zone depletion levels. In summary, when comparing WaterSage to some of the key smart irrigation controller factors, we see its weather source is a commercial weather station right on campus. It is compatible with any third-party rain sensor, and a Hunter wireless sensor is provided as a part of the pilot. It makes irrigation adjustments based on daily weather, or with your new knowledge, ET and precipitation, as well as landscape settings. Is accessible virtually anywhere from a smartphone, tablet, or computer. Is easy to install, and is easy to program, with detailed how-to videos and documentation available from the OnPoint website. Post-installation, WaterSage has built-in diagnostics, on-screen help, automatic online upgrades for updates and new features, and of course, feel free to contact OnPoint with questions or if you need assistance. And unlike some smart controllers, WaterSage has no subscription fees. For more information or questions, please contact us via email or phone as shown here. For Stanford pilot participants, please contact us directly to purchase your WaterSage controller. We also invite you to watch the various WaterSage videos on our website. Thank you, and let's all save water.
Thank you, Dan. Here are a few quotes from pilot study participants, highlighting features such as easy remote access and adjustments for each zone based on the weather and landscape factors. Thank you for joining us for this information session on weather-based or smart irrigation controllers. If you have questions on Stanford's pilot study or general information about weather-based irrigation controllers, you can contact me or my colleague, Erica Kudaba. For questions about OnPoint Ecosystems controllers, please contact Dan Palmer. Also, check out our water efficiency website for lots of other information.